All right, let's learn all about probability. So probability is the chances of you getting what you want compared to all the possible outcomes. So it could be your chances of flipping a coin, rolling a specific number on a dice, or in this case, picking a specific type of candy. So let's say there's these candies available. Altogether, there are 10 pieces to choose from. So the probability of a child picking a jelly bean is, well, there are 2 jelly beans out of 10 possible pieces of candy, so 2/10. You might be asked to convert it to a percent. So you would do 2 divided by 10. I'll actually type in the middle part, which would be 0 and 2/10. And then you move the decimal 2 to the right. So after the 2 and after the nothing, and nothing's the same as 0, which brings it to 20%. So that would be unlikely. The probability of a child picking a candy without a stick. Well, the blue ones and the yellow ones and the purple one don't have a stick. So it would be 7 out of 10, which would end up being 70%. And that would actually be likely, since it's more than half. All right, there's also something called independent probability, which is where more than one thing is happening, but they don't affect each other. All right, so let's say we are either spinning a spinner with just these 4 numbers, rolling a die, flipping a coin, or choosing from just these 3 cards. Okay, so we want the probability of 3 things happening. We want to spin the number 4, roll an even number, and then flip the coin and have it land on tails. Okay, so let's start with spinning a 4. 4 is one of the 4 numbers on the spinner, so that would be 1/4. Then rolling an even number. 3 of the 6 sides are even. That simplifies to 1/2. So we're going to do 1/4 times 1/2, but also times our next fraction. So flipping a coin and getting tails would also be 1/2. So if we multiply all of that together, 1 times 1 times 1 on top is 1. And on the bottom, 4 times 2 is 8, and 8 times 2 is 16. So 1/16. All right, so that would be our final probability, and that again would be something that is unlikely. All right, drawing a heart, rolling a number greater than 2, or spinning an odd number. Okay, drawing a heart, there are 2 hearts out of the 3 cards. So our first fraction would be, 2/3. Then rolling a number greater than 2. So on the dice, there's 6 numbers. 1 is less than 2, 2 is equal to 2, so we'd have 3, 4, 5, and 6. So 4 of those 6 numbers, which is also the same as 2/3. And then spinning an odd number. 1 and 3 are odd, so 2 of those 4 numbers on the spinner, and that's the same as 1/2. And I could still put 2/4 here, but then I'll have to simplify a lot at the end. So it's easier to simplify ahead of time. All right, let's multiply those numerators. 2 times 2 is 4, and 4 times 1 is 4. On the bottom, 3 times 3 is 9, and 9 times 2 is 18. And oops, that should be a fraction bar instead of a comma. And then that could simplify to 2/9. All right, let's talk about another one. Let's say we are going on a trip, and we want to pack as few clothes as possible. So we're going to pack a pair of jeans and a pair of khakis. For a shirt, we're going to pack a black, a white, and a gray shirt. And we're going to pack a sweatshirt and a jacket, just in case it's cold, and then tennis shoes and sandals. Okay, and then we're just going to mix and match these each day. All right, so how many possible outfit combinations are there? Okay, so what we're going to do is we're going to find the number of total options for each. So we have 2 pants to choose from, and we have 3 shirts to choose from, and we have 2 cover-ups to choose from, and then we have 2 pairs of shoes to choose from. So if we multiply these all together, let's see, 2 times 3 is 6, 6 times 2 is 12, and 12 times 2 is 24. So I have 24 different outfits that I could wear if I mix and match all the stuff. Now, yes, it might be sometimes nasty to wear things more than once, but maybe we have access to a washing machine. All right, what is the probability that a traveler will wear jeans with a white shirt and a jacket? Okay, well, their chances of wearing jeans are half because they have 2 options to choose from, and one of those pant options is jeans. All right, then a white shirt. A white shirt is one of the 3 shirt possibilities. And then a jacket. Well, they have a sweatshirt or a jacket. So there's a, whoa! There is a 1/2 chance that they are going to pick a jacket. So we would multiply all of those together. All right, I'm going to skip that last one there because I don't want this video to be super long. Let's go to this one. All right, this is an example of something called dependent probability, where the probability of the second thing depends on what happens first. Okay, so let's say we have this claw machine, and this claw machine is set up so every single time you play, you are a winner. So what is the probability of winning a monkey and then a lion? All right, so the monkey is one of the 8 animals. So our first fraction would be 1/8. And you get to keep that monkey. You're not going to put it back in, so I'm going to cross it off. That monkey is no longer there. Now the chances of winning a lion are 4 out of 7. There's no longer 8 animals in the claw machine. There's only 7. So our second fraction would be 4/7, and then you would multiply straight across to get your answer. And then simplify. I just didn't for this one. All right, what is the probability of winning a panda? I'm going to remove that X because this is like a fresh question. All right, so for the pandas, 3 of the 8 stuffed animals are pandas. And then I'm going to cross one out because we took that out of the claw machine. It's no longer there. So now instead of 8 animals, there's only 7. So the probability of getting another panda, ooh, there's not 3 anymore either. There's only 2. So our second fraction would be 2/7. Okay, so you're going to have some examples like this today, either with a claw machine. There's going to be some that are fishing, some where food is eaten up and taken away. So make sure you double check your second fraction.